Hey everyone, welcome to Unit 13. In this unit, we have a guided notes packet, which will be really nice because there's lots of word problems, so that will help you to not have to write down so much. So make sure that you have one of those before we get started. Unit 13 and Unit 14 are two of my favorites of the year, and I'm glad we saved them for last. In this unit, we're counting outcomes, which is a precursor to our probability unit that's coming up next. So I hope you guys enjoy this. It's different. It's not very much related to geometry, so something different to end the school year with. So make sure you have a packet, and then we'll go ahead and get started. 13.1 is about the fundamental counting principle, and we're going to break this one up into two chunks. So this one is counting principle A, and we're going to get started with a problem right away, a little exploration here, so we can make sure that we have an idea of kind of where this is headed. So you're buying a new car, yay! You have three colors you can choose from for your car. You can have a black one, a green one, or a red one. You can choose from two different body styles, the sedan or the hatchback. And then there's also three different models or trims, they're sometimes called. So S, maybe more the basic model, L, and then P, maybe the fancier model. So first thing we're going to do is we're going to make a tree diagram. And what a tree diagram does is it is basically a visual of your sample space or a picture of all of the different possibilities of cars that you could have. So I'm going to make this one kind of like a horizontal one, and you can draw your tree diagram however it best fits on your paper or however it makes the most sense to you, but I'm going to draw it this way. So I'm going to start with the color. So we could have a black one or a green one or a red car. Okay. And then for each of those, we can choose between sedan or hatchback. So we could choose a black one and we could have sedan or hatchback. Or we could choose a green car and it could be either a sedan or a hatchback. And then for R, same thing, sedan or hatchback. So I'm just going to kind of remind us of what this is here. This is our color. This is our style. And then this last one is going to be the model. And we got to write kind of small for the model here. So each of them is going to get three different models. Whoops, got kind of weird. Okay, so we could have S or L or P. That is our model. All right, that's a tree diagram. That's it. It's just a visual of your car choices. Maybe you want to give it a title, if I could spell. CHOIC. Car choices. Okay. So one thing you can do with a tree diagram is you can count your possible outcomes, and you can do that by just counting the items in your very last row. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 possible cars to choose from. All right, the sample space. This part can get a little bit annoying and tedious, but what your sample space is it is just a list of all of your possible outcomes. So really no different than what we just did, except we are literally going to list each car combination. So I always start kind of on the left-hand side or on the top if you drew it the other way, and we're just going to follow each tree branch. So we could have a BSS. That would stand for a black sedan. That is the style or the model S. Okay, or we could have a BSL or a BSP. All right. Then we could have a BHS, a BHL, or a BHP. And on to the next one. We could have a GSS. That would be a green sedan style S. Or a GSL or a GSP. We could have, let me switch colors again, go back to red. We could have a GHS or a GHL or a GHP. All right, keep on going. We could have an RSS. We could have an RSL or an RSP. And then we could have an RHS, an RHL, or an RHP. All right, so there is all 18 possible outcomes. 3, 6, 9, 12, 15, and 18 possible outcomes. Okay, so I purposely chose one that was kind of tedious to do here because that's about as bad as it's gonna get. If we have any more outcomes than that, we're probably not gonna be listing every single outcome. We're gonna have some tools, some shortcuts so that we don't have to do that every time. But in a situation like this, I think it's nice to see all of the possible cars. Okay, so moving on to a couple more practice problems here. This first one, letter A, it says if you play a game where you toss a coin 5 times, we're actually going to change that to a 3. I think 5 is kind of ridiculous. It's going to take us too long. So we're going to change that to a 3. So you play a game, you toss a coin 3 times. What are all of the combinations that could happen? We're going to make a tree diagram, and then we're going to list the sample space. Okay, so this time I'm going to draw the tree diagram this way. So this is a coin toss. Coin toss 3 times. All right, if you're flipping a coin, you could get either heads or you could get tails on your first toss. Okay, then you're going to go again. And if you got heads the first time, you could also get heads the second time, or on your second toss, you could get a tails. With tails, you could get a heads for your second toss or a tails for your second toss. Toss 2. All right, and then finally toss 3. We could get heads or tails, heads or tails, heads or tails, heads or tails. That is our third toss. All right, so how many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And then for our sample space, remember that's where we're going to list all of the possible outcomes. This one won't be quite so bad because there's only 8 outcomes instead of 18. So heads, heads, heads. We could get all 3 heads. We could get heads, heads, tails. We could get heads, tails, heads. Or we could get heads, tails, tails. Okay, that's the first half. That's all of the choices, all of the outcomes when heads is first. Now we'll do the same thing for tails. So tails, heads, heads. We could have tails, heads, tails. We could have tails, tails, heads. Or we could have tails, tails, tails. All 8 outcomes. All right, moving on to example B. If you go shopping and you buy 4 shirts, your shirts could be red, blue, green, or purple, 3 jackets, blue, green, and red, and 2 pairs of pants that all go together and have the same colors. Make a tree diagram to see how many different outfits you can make without repeating. Okay, so the good news with this one is we don't have to list the sample space once we're done. We just need to make that tree diagram. So I'm going to start with the shirts, and we need 4 branches. We need red, blue, green, and purple. And then we're done. And then from there, we need 3 jackets. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This gets a little bit messy. Blue, green, red. Blue, green, red. Ugh. And then finally, pants. So each of these get 2 pants. Okay, I'm going to stop right there. The point of this is that this is yucky. Okay. It gets too hard. If you start to have too many things in your tree diagram, it just gets too messy. Okay. I can't even read that. I mean, maybe you guys did a better job on yours, but on my smartboard here, when I'm doing that, I can't even tell what's going on there. So we need a better way. If you look at this example C, that one's even worse. There's 5 types of bread and 7 types of meat and 4 types of cheese and 10 condiments. You can't possibly do that with a tree diagram. It's just too big to be reasonable. So that's where we get to the fundamental counting principle. And the fundamental counting principle says that when there are m ways to do one thing and n ways to do another, then there are m times n ways of doing both. So basically what you need to do is you need to take your possibilities and you need to multiply them all together. So if we go back to our car buying situation, we had 3 colors, 2 body styles, and 3 models. If we were to just multiply those together, 3 times 2 times 3, 3 times 2 is 6, and 6 times 3 is 18. So that's how we could have gotten our 18 outcomes. Sure, it was nice to list all of them, but if we just wanted to know how many outcomes there were, the fundamental counting principle probably would have been easier. If we go to our coin toss, our letter A, maybe let's off to the side here use our fundamental counting principle. There were 2 possibilities for our first toss, heads or tails. There were 2 possibilities for our second toss, heads or tails. There were 2 possibilities for a third toss, heads or tails. Okay, so altogether, 2 times 2 is 4, times another 2 is 8. And that's how we can get our 8 possible outcomes. Okay, if we go back down to our letter B, which got too messy to even put up with, we could use our fundamental counting principle and we could say, okay, we had 4 shirts, we had 3 jackets, and we had 2 pairs of pants. 4 times 3 is 12. 12 times 2 is 24. There are 24 possible outcomes. All right. And we sort of have the tree diagram started. So if we really wanted to find an outfit there, I think we could. All right. So go ahead and complete practice 13.1. Some of these practices, they look a little bit longer, but that's just because there's a lot of words. So they shouldn't take you too awful long. Make sure you do that. Make sure you check your answers. And then once you're done with that, I need to see both your notes and your practice. I'm really going to make sure that you guys are doing your notes and filling out this packet. So show me both of those before you move on to 13.2.